Hello. Um, so today I'll be explaining these questions on this video. So let's get started. So the first question is asking the vector space. The vector space R2 is not a subspace of R3 because R2 is not even a subset of R3. So what this is basically saying that over here, this plane vector, whatever, is acting as R2, but in reality is R3. But what does this mean? So in vector space by definition is a collection of vectors where you can add vectors together and multiply them by scalars or numbers per se. And we have to follow specific rules for these, of course. And then we also have a subspace, which is a smaller vector space within a larger one, which also follow the same vector space rules. So what does all of this mean? Like, let's say we have R2 here, and then we have R3 here. So in R2, you only have vectors in the form of two components. So X and Y. And then for R3, you have vectors with components like X, Y. Actually, let's do A, B, and C, just to keep it, different or whatever. So R2, this one, is not a subset. Oh, it's not a subset of R3 because they have different numbers of components, aka different variables, components. This is what it is basically trying to say in here. So then they give us the set over here. So what this set is trying to say is um, H consists of vectors in R3. So there are vectors of R3 in H. You have S, you have T, and you have 0. So these 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 two they can be any real numbers, but the last one, to keep it consistent with H, it must be 0. The last one cannot be any other number than 0, but this one can be any real number. Okay, so um, by this we can say that in H we can have the vectors 0, 0, 0, which it also like fits, with the form that we currently have it, as in ST0. They both fit in it. They're, I don't want to say they're the same thing, but they're similar. Okay. An example for these, I will say, um, I have, let's take S1, T1, and 0, and let's also take S2, T2, and 0. So there's some, oh, okay. Their sum will be this. So will be this S1 plus S2, T1 plus T2, and of course 0. What I like about this is that all of these of what I've done so far is still in H. So like all of what I'm doing in here is true. As long as this number over here, the third vector, vector C, whatever, I mean component C, remains on 0, all of what happening here must be true in here in this plane. Okay, we can also do close under scalar multiplications, which is basically, you know, taking the product of like any number. Let's say we have C, and then we also have, you know, these. Well, you basically just multiply it. So you will have CS, CT, and 0. That will be the answer, which it is still on A. So that's my explanation for question number one. Uh, so for the second question, it's asking us to show that the set H of all points in R2 of the form 3s, comma, 2 plus 5s is not a vector space by showing that it is not closed under scalar multiplication. And a specific vector u in H and a scalar c such that cu is not in H. Um, so what is this asking us to do? So we have already talked about what vector space is and also what a subspace is. So set H, it is defined as the collection of all points in R2. So all points in R2 um, of the form 3s, comma 2 plus 5s, where s is a real number. So let's take as an example when s equals 1, the vector will be, okay, so we have these, then we have these. So it will be 3, comma 7. This will be our vector. When s equals 0, it will just be 0, comma 2. Okay, so um, so let's take u, 3, comma 2 plus 5, and then let's choose s equals 1. So our u will be equal to 3, comma 7. And then we also must choose a scalar. So let's pick c equals 2. And now let's try and multiply, or compute the vector by the scalar. So how do we do this? So we just compute c u. In other terms will be 2 times 3, 7, or 6, comma 14. So with this answer, we need to check if it is in H. And how do we do that? So, so if 6 comma 14 is in H, there must be some S such that 3s comma 2 plus 5s equals 6 comma 14. So what does this mean? This means that 3s equals 6 and 2 plus 5s equals 14. So from 3s, we solve for this and we get s equals 2. And then we plug in these 2 into 2 plus 5s, of course. And we get as an answer, we get as an answer 12, which is not 14, how we originally have discovered over here. So since there is no single value of s that satisfies both equations simultaneously, this is not in H. So since like we already multiply by scalar c equals 2, H is not closed under scalar multiplication, and therefore this this form of R2 is not a vector space. Question 3 is asking us um, two different questions. Determine if U is in node A, and then second question from question A, could U be in column A? So how do we do this? We first do the augmented matrix, of course. So A times U equals 0. Gotta say that we have the both vectors here. We have A, we have U, and we have B. So for question A, um, I went ahead and solved it. So it gives us a value. Okay, let me set it up and then just go straight to the answer. So we have these values, 7, -2, 7, -8, 1, 3, 6. Then we have the other vector, 1 and 0, right? Yes. Okay. So the answer that we get from solving this will be 0, -3, 3, right? So since A U does not equal to 0, U is not in no A, but it's also asking us a second question. Could you be in column A? Can you be in column A? So for this, we need to check if U can be expressed as a linear combination of the column A. So for this, we will need to, you know, set up set up an augmented matrix and perform row reduction to see if there is a solution. So um, by performing the row reduction matrix, I will not be doing the process on that as the video will take, you know, minutes and minutes and minutes. I'm pretty sure that you guys can you know, find a software online or something to help you understand how row reduction works. But ultimately, if you do all the math here and here and here, you end up getting. So the row reduction for this will be 2, 0, 0, 4, negative 1, 0, negative 2, 5, 0, 1, 4, 8.5, 3, 1, negative 4.5. So, so the third row indicates an inconsistent system as it cannot have a non-zero value on the right-hand side. Therefore, there is no solution in U. U is not in call A based on the row reduction. So, no. So for question B, we're gonna try and do something very similar as well. So we're gonna determine if B is equal A. So we first need to set up the augmented matrix. And we get as the answer. Sorry, I was looking at my paper trying to understand all the math and everything. We get as an answer this 2, 0, 0. This will be the reduced echelon form, row reduce, however you want to call it. So 5, 0, 1, 4, 8.5, 3, 2.5. So again, just like the last one, um, the third row indicates an inconsistent system as it cannot have a non-zero value on the right-hand side. So therefore, there is no solution in B. So it is not in code A. So it's asking us, could B be in node A? Let's find out. As we did before, we did a bunch of math in here. So we're gonna have, the same. Let's take the same thing here. So now we need to perform the multiplication. So 2 over 3, 2 times 3, sorry, 2 times 3, 3, 3, then 4 minus 1, minus 1, plus, 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 and then we're gonna have 7 minus 1, plus, plus, plus -2, 3, 7, 3, -8, and 3. And this is going to give us the answer -4, 20, 22. So based on this answer, AB is not equal to 0. So B is not in no A. Well, that was all for all three questions. Thank you.